Okay, for those of you that are still trying to figure out how to get this done prior to your test, we're going to go ahead and go over this. I went ahead and changed the numbers so that it's not the same as yours, but you can follow along and do your own calculations. Okay, so the first thing we're going to start off with is how to calculate the molar mass. That's something we've been going over for 5 weeks now, and so it's not a difficult process. It's just something that you've got to remember what to do. Okay, so for the first one, you've got C2H6. So this is telling you have 2 moles of carbon. So this 2, you're going to write 2 moles because of that 2. Okay, so then because this hydrogen has a 6, you're going to go ahead and write down that hydrogen has 6 moles. Okay, now that you've established how many moles of each element, you're going to go ahead and multiply each one by the mass on the periodic table. So since this is an element carbon, you're going to take the periodic table, look up carbon. There it is, and it's 12.011. So you go back to this, and you're going to multiply that too by the mass on the periodic table, which is 12.011 grams. Okay, you're going to do the same thing with the hydrogen. You're going to find the hydrogen. There it is. It's 1.088. And you're going to multiply the 6 moles by 1.008. Okay, so by multiplying the 2 and 12.011, you get 24.022. You multiply the 6 by 1.08008, you get 6.48. So now that you have those numbers, you add them together. By adding them together, you get 30.07 grams per mole, because that is a unit for molar mass. So doing the same concept, if you already know what to do, you can go ahead and do it on your own. If you're still struggling, just follow along. So here we have carbon dioxide. Notice that there's not a number here, so it's understood as a 1. So just like you did over here, you're going to write down that you have 1 mole of carbon. This too indicates that you have 2 moles of oxygen. Okay, so now that you have those 2, you're going to, because that's the only 2 elements we have, you're going to multiply by their masses on the periodic table. Remember, we already know what the mass of carbon is. It's 12.011. And the mass for oxygen on the periodic table, if we look it up, is 15.999. Okay, as indicated right there. Okay, just like you did on the previous example, you're going to take that 1, multiply it by 12.011. You're going to take that 2 and multiply it by 15.999. So 1 times 12.011 is 12.011. Okay, then we have 2 times 15.999 right here. Multiplying that, that gives us 31.998. See, it's the same process as we did here. Once we multiplied, the next thing to do and the last thing to do is to add the 2 numbers. So we're going to add 12.011 with 31.998. Okay, adding those 2 together, we get a total of 44.009 grams per mole, because again, that is a unit for the molar mass, or any molar mass. Okay, so far we've done 2, the same process. Here's the third one. Okay, so we've got water, and this is indicating that we have 2 moles of hydrogen. This doesn't have a number, so just like we established with the carbon here, When they don't have numbers, they're understood as 1. So it's going to be 1 mole of oxygen. So now we're going to multiply each one by the mass on the periodic table. Remember, we already saw that hydrogen is 1.008. So that's the mass on the periodic table. And oxygen, we had looked it up and we established that it was 15.999. Just like we did on the first, just like we did in the second, we're going to multiply the number of moles by the mass on the periodic table. Okay, once you multiply them, you'll find that you have 15.999 and 2.016. So now you add the 2. Okay, so adding the 2 numbers, we get 18.015. So pretty much the same steps. Separate the elements, find out how many moles each element has, multiply by those masses on the periodic table. Those answers, add them up, and there's your molar mass. Simple steps, and that's what you do every single time. Okay, for the next question, it's mole conversions, which is what we did prior to stoichiometry. And you actually have notes that go with that I made a copy of for you. I believe they are on page 3 in your ISN. So just look through those notes and you're going to find that there is a method to do this. Okay, but I went ahead and wrote it on today's paper. So I changed the numbers as I had mentioned before. You can go ahead and follow along. All you need to know is that your number will be plugged in rather than mine. Okay, so the question is asking what is the mass in grams of 2.5 times 10 to the 7 moles of H2O. So they're asking for the mass of water and they're giving you the moles. Okay, so here we go. How do we know that's our given? If you read through the question, the given is identified as the number that's in the question, along with everything else that it tells you about that number. So here, the number is 2.5 times 10 to the 7. That's our given. And I'm going to say that again. Our given is the numerical value or values given in the question. So that was given to us. And then it gives us a little bit more information. It's saying that this number represents moles of water. So it's 2.5 times 10 to the 7 moles of water. The question that is being asked, or what they want us to find, is what is the mass in grams? So what we're looking for is the mass in grams. So we're looking, or this type of problem is a mole to mass problem. So if you look at your notes, like I said in your ISN, mole to mass problem, this is the setup. This is what we need to follow. I just finished explaining how to figure out what type of problem it is, and your job is to go back and find out what notes you would use. Okay, so this is telling me to put my given moles of A. A represents the symbol of that chemical that's in the given. So in this case, the symbol of the substance or chemical is H2O. So H2O is really representing A. Okay, so it's telling us to put the given in moles of A. So the given in moles of H2O. So this number right here goes here just like it does in the setup. Okay, so my given was placed here just like in the setup. And then it says to put 1 mole of A. And remember we established that A is that chemical symbol that's in the given. So it's going to be 1 mole of H2O. Okay, right above it, it says we need to put the molar mass in grams of A, which is again still H2O. So we need to get the molar mass of H2O. But this was set up in a way where you would have already figured it out. So our molar mass, which is what we had to calculate for numbers 1, 2, and 3, our molar mass of water is 18.015 grams per mole. So that means that that number goes here. 18.015. This is a grams, this is a per mole part. Okay, so we've already finished setting up the problem. So now all you have to do is put it into the calculator. So we're going to put 2.5 times 10 to the 7th multiplied by 18.015. Whatever that number comes out to, divided by 1, which anything divided or multiplied by 1 is the same thing. When you're entering this number into the calculator, you would enter it as 2.5, and there's a button which is the exponential function that says EE. So you would put 2.5, press that EE button, 7 times 18.015. All right, so once again, when we multiply 2.5 times 10 to the 7th by 18.015, what you're going to get is 450,375,000 grams of H2O. And just in case you're wondering, how is it that this is not a multiplication problem in itself? It's not. It's a number in scientific notation. So if you were to move the decimal 7 times, in standard form, it would be read as 25 million. So it would be 25 million times 18.015, and you'd still get your 450,375,000 grams. Okay, for question 3, it's asking how many molecules are in 8.5 moles of H2O. So, like I said before, if you still don't understand what your given is the only number value at this point in the question. So my given is 8.5 moles of H2O, and you put the rest of the information behind it. So that's my given, and they're asking how many molecules. So they're asking me to find molecules. This is a mole to molecule type of problem. So if you look at your notes once again, this is a setup where you place the given in moles, you use Avogadro's number over 1 mole. Okay, so our given is going to go in this box right here. So we're going to put the 8.5 moles of H2O. Okay, right next to it, just like it says in the setup, we're going to put 6.02 times 10 to the 23rd molecules. And it says of A. And just like I explained it earlier, the formula for that chemical happens to be A if it's in the given. So A is also repeated here. So that's going to be also H2O. And down here, it's going to be 1 mole of A, which is H2O. Okay. Remember that everything should cancel diagonally whenever you place these numbers. So just like we did here, this should match diagonally with what's here. Okay, so for the math, just like I asked you before or showed you before, you're multiplying across and dividing by the bottom. So in this case, it would be 8.5 multiplied by 6.02 times 10 to the 23rd. Remember, when you're entering this number in the calculator, rather than putting times 10, it's a lot easier to go ahead and use a button that has 2 E's, because that stands for the exponent, and then you put the 23, and you don't have to put the times 10. Okay, once we multiply the 8.5 times this number, it gives us 5.12 times 10 to the 24th molecules of A, so molecules of H2O, which is the original compound used in the given. Okay, for numbers 6 and 7, they're asking you for the ratio of ethane to water. This is actually pretty simple. All you've got to do is look for the coefficients. Anytime you're doing or using the molar ratios, you are using those coefficients in the balance equations. So ethane, we know here it's pointing to this compound. So it's 2. So ethane is 2. And water, if we look at water, it's 6. Okay, so this is a 2 to 6 ratio. Okay, for the next one, what is the ratio of oxygen to carbon dioxide? Okay, so we look at oxygen. That is a 7. And then to carbon dioxide, which is a 4. So in this case, the ratio is 7 to 4. For number 8, we're going to do stoichiometric problems. So we're having to use the balanced equation to figure these out. For number 8, it's asking, it says if 13 moles of O2 are used up in the reaction, how many grams of H2O are produced? So kind of like what we did before, find out what your given is and what they're asking you to find. So the given in this case, again, the only number value. So it's 13 moles of O2. As you can see, there's no other number here, and that's our given. What are they asking us to find? Pretty much the question. How many grams of H2O? So we're going to find some number of grams of H2O. Okay, so if you look at your foldable, and you're trying to find out which section to use. Okay, this is a mole to grams is mass. Grams is just the unit for mass. So we're trying to find the mole to mass setup. Okay, and this is what it should look like in your foldable. You're going to use this to set up the problem. If you can use this, I mean, you're pretty much set. You could do exactly what it's asking you to do. Okay, so it says to put the given moles of A. So it's 13 moles O2. Remember, O2 is now going to represent A because that's the compound or substance in the given. In this case, it's the molecule oxygen. So 13 moles of O2. So given, which is our 13 moles, A is our O2. Okay, in the next step, it's the ratio step in which we're going to have number of moles of B over number of moles of A. So whenever you see this in the notes, this pound sign, you're going to use the coefficients. The coefficients are those numbers that are in front of the substances that are in the balanced equation. So in this case, the coefficients here are 2, 7, 4, and 6. So those are the ones we're using here in according to what compound element or for that matter any substance that we're using for these. Okay, so this is a certain number of moles of A. So we know A is O2. So something moles of O2. Okay, that number is going to be the number or the coefficient that's here in the balanced equation. So it's going to be a 7. Okay, then it says number of moles of B. Again, we see the pound sign, and anytime we see the pound sign, I want you to think to use the coefficients. So again, in your notes, when you see this, use the coefficients. So this is moles of B. B happens to be the substance that you're trying to find. So in this case, what we're trying to find is H2O. So O2 represents A, and H2O represents B. So this is going to be moles of H2O. For this pound sign, we're going to substitute it with the coefficient for H2O. So looking at this, the coefficient is 6. And it looks like that. Okay, so moving along to the next step, it says 1 mole of B, molar mass of B. So B is H2O, so we're going to put 1 mole of H2O. And then we're going to write down molar mass, which is in grams of B. And again, B is H2O. So remember that the molar mass is what we found in the very first 3 questions, which we already know what that is. Okay, so here's a molar mass of water is 18.015. And that goes in this section right here. Okay, so we filled out everything in our dimensional analysis for the stoichiometry. So what you're going to do now is you're going to take these numbers and you're going to multiply them across. So you're going to do 13 times 6 times 18.05. You're going to do the same thing with the bottom numbers. 7 times 1. Okay, doing the math, we've discovered that by multiplying these 3 numbers, we get 1,405.17. Doing the math on the bottom, 7 times 1, we discover that it's 7. Now we take the top number and divide it by the bottom number. Okay, so once we divided the 2, we get 200.74 grams of B, which is H2O, grams of H2O. And if you notice, what they were asking us to find is to find the grams of water, and that's exactly what we did. Okay, for number 9, it's asking how many moles of CO2 does it take to produce 1.25 times 10 to the 5th grams of C2H6. Okay, so therefore, we're going to put our given. Again, we look for the number. It's 1.25 times 10 to the 5th grams of C2H6. Okay, and they're asking us to find some number of moles of carbon dioxide. Okay, so this is mass to mole. So a mass to mole problem. So now in the foldable, you look for the setup for a mass to mole. You should have this written down. Okay, so we're going to follow it along just like we did here. Okay, so it says to put the given grams of A. So our given is 1.25 times 10 to the 5th grams of C2H6. Okay, so did that. Now it says to put 1 mole of A. So in this case, A is going to be C2H6. So again, remember A represents the chemical that's in the given. So this is our chemical in the given for number 9. Okay, so it's going to be 1 mole of C2H6. And underneath it, we're going to put the molar mass in grams of C2H6. Okay, so we already know that information. Here's a molar mass of C2H6 that we did at the beginning. And so it's 30.07. And that's going to go down here. 30.07 grams of C2H6. Okay, so now the next step is the ratio step. Okay, so we're trying to get the molar ratios. And to get those molar ratios, we're looking at the coefficients. So in this case, we're looking for number of moles of B over number of moles of A. A represents C2H6, so it's going to be so many moles of C2H6. And remember, this pound sign, just like I said earlier, is going to represent the coefficients. So C2H6, I'll look it up. Here's C2H6, and the coefficient is 2. So that's going to have a 2 here. And this is going to be a certain number of moles of B. And B is the one in what we're trying to find. So it's CO2. Now we have to look for the coefficient for CO2. Looking back at our formula or an equation, it's 4 for the coefficient. Okay, so we filled up all the boxes. All we have to do is just like we did for every other single one we've done. We multiply the numbers across, multiply also the numbers across on the bottom, and divide the top by the bottom number. Okay, so multiplying the top numbers, we get 500,000. Multiplying the bottom numbers, we get 60.14. Okay, so now we divide the top by the bottom number, and our total is going to be 8,313.93 moles of carbon dioxide. And just in case you just missed it, again, you're going to take this number, multiplied by this number, multiplied by this number to get this answer. You're going to take this number, multiply by this number to get this answer, and now take the top answer divided by the bottom answer to get your final moles of CO2. Okay, so now for our last stoichiometry problem. It's asking for how many grams of C2H6 of ethane are needed to produce 90 grams of H2O, water. Okay, so our given is our 90 grams of water, and they're asking us to find grams of ethane, C2H6. So our given is grams, which is mass, and they want us to find mass. So this is a mass to mass problem. So in your foldable, you would look for the setup that looks like this, mass to mass. Okay, so you should have this in your foldable for your setup, and you're going to follow along just like you've done for all the other ones. So it says to put the given grams of A. A is H2O in this problem. So it's going to be 90 grams of H2O. Okay, and then in the next step, it tells us to put 1 mole of A. A is H2O. So 1 mole of H2O. Okay, on the bottom step, it tells us to put the molar mass in grams of A. So it's going to be grams of H2O. And we've already done the molar mass of H2O. And we did it here earlier. And it's 18.015. Okay, so then our next step, according to our setup, this is where we do the molar ratios and we use the coefficients. So this is saying to do moles of A, which is H2O. And then this is saying to do moles of B. And in this case, B would be what we're trying to find, which is C2H6. Remember where we see the pound sign, those are the coefficients in the balanced equation. So for C2H6, it's 2, and for H2O, it is 6. It looks like that. Okay, so then according to the setup, it says 1 mole of B. So B is C2H6. So it's going to be 1 mole of C2H6. And everything still is diagonally the same. And the molar mass in grams of B. B being, again, C2H6. Okay, we've already found the molar mass of B. So going back to our original information, it's 30.07. So we're going to put 30.07, just like that. Okay, good news is we filled it up. So now just like we did the other ones, you're going to multiply the numbers across. So the 90 times a 1 times a 2 times a 30.07, whatever answer that gives you, you're going to divide by the answer you get by multiplying 18.015 times 6 times 1. Alright, so multiplying those top numbers like I had mentioned, you get 5,412.6. Multiplying those numbers on the bottom, you get 108.09. Now divide the top by the bottom and you get 50.07 grams of B, which is C2H6, so grams of C2H6. And that's how you get the mass to mass problem.